This is an audiovisual presentation of indices. Now let's look at the laws of indices. Law number 1. A raised to the power m times a raised to the power n is equal to a raised to the power m plus n. That is when you have numbers or variables of the same basis multiplying. When you keep one of the bases constant, you add the exponent together. And so a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. Example, if you have 2 raised to the power 3 times 2 raised to the power 2, because they are of the same basis and the base is 2, according to the first law of indices, we keep one of the bases constant, and that is 2, and we add the exponent together, and the exponents are 3 and 2. So adding the exponent together, we have 3 plus 2. This means that 2 raised to the power 3 times 2 raised to the power 2 is equal to 2 raised to the power 3 plus 2. And this is equal to 2 raised to the power 5, because 3 plus 2 is equal to 5. And 2 raised to the power 5 is equal to 32. Example, 3 raised to the power 3 times 1. 3 raised to the power 3 times 1. This is equal to 3 raised to the power 3. Take note that 1 is equal to 3 raised to the power 0. That is, any number raised to the power 0 equals 1. And therefore, because the base we have here is 3, that means that we can also express 1 to the base 3 of an exponent 0. And so 3 raised to the power 3 times 1 is equal to 3 raised to the power 3 times 3 raised to the power 0. Now, these are numbers of the same basis multiplying. And according to the first law of indices, we keep one of the bases constant and we add the exponent together. And so we have 3 raised to the power 3 plus 0. And this is equal to 3 raised to the power 3. Now 3 raised to the power 3 is equal to 27. 3 raised to the power 3 is equal to 27. Law number 2. A raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. Now, if you have numbers of the same basis or variables of the same basis dividing, according to the second law of indices, when you keep one of the bases constant, you will subtract the powers. Example, 3 raised to the power 3 divided by 3 raised to the power 2 is equal to 3 raised to the power 3 minus 2. Because the numbers are dividing, when we keep one of the bases constant, that is 3, we subtract the exponents. And so we have 3 minus 2. Now 3 raised to the power 3 minus 2 is equal to 3 raised to the power 1. And 3 raised to the power 1 is equal to 3. Now, law number 3. A raised to the power m into bracket exponent n is equal to a raised to the power m times n. That is according to the third law of indices. If you have a number raised to an exponent in brackets, or raised to an exponent, the exponent in the bracket has a chance of multiplying the exponent outside the bracket. And so a raised to the power m all exponent n is equal to a raised to the power m times n. And when you multiply m by n, the result is mn. And therefore this is equal to a raised to the power mn. Now let's look at this example. 2 raised to the power 3 all exponent 2. This is equal to, according to the third law of indices, is equal to 2 raised to the power 3 times 2. Is equal to 2 raised to the power 3 times 2. That is 3 times the exponent outside the bracket. And now when you multiply 3 by 2, the result is 6. So 2 raised to the power 3, 2 raised to the power 3 times 2 is equal to 2 raised to the power 6. And 2 raised to the power 6 is equal to 64. Now let's look at this proof. We were given 2 raised to the power 3 exponent 2. And so given 2 raised to the power 3 exponent 2, solving the bracket first, 2 raised to the power 3 alone is giving us 8. Don't forget your exponent. The exponent is 2. This means that 2 raised to the power 3 all square is equal to 8 square. And now 8 raised to the power 2 is equal to 64. And these are the same answers. It is the same answer. And that is the proof of law number 3. Now example, express as single powers in the following. A raised to the power 3 times a raised to the power 2, all divided by a raised to the power 6. B 3 raised to the power 4 times 3 raised to the power 5 times 3 raised to the power 2, all divided by 3 raised to the power 6 times 3 raised to the power 3. Now let's look at the solution. A raised to the power 3 times a raised to the power 2, all divided by a raised to the power 6. We can see, when we look at the numerator, we can see that the variables are of the same basis, and the base is a. They are the same, and so according to the first law of indices, we keep one of the basis constant, that is a, and we add the exponent together, and so 3 plus 2 is equal to 5. So a raised to the power 3 times a raised to the power 2 is equal to a raised to the power 5. Don't forget, it's all divided by a raised to the power 6. Now a raised to the power 5 divided by a raised to the power 6 can also be expressed as a raised to the power 5 divided by a raised to the power 6. Now these are variables of the same basis, and the base is a. And so because the numbers are dividing, according to the second law, we subtract the exponent. And so a raised to the power 5 divided by a raised to the power 6 is equal to a raised to the power 5 minus 6. And 5 minus 6 is giving us minus 1. This means that a raised to the power 5 minus 6 is equal to a raised to the power minus 1. And a raised to the power minus 1 is equal to the reciprocal of the number, that is 1 over the number. A raised to the power minus 1 is equal to 1 over the number. Now B, 3 raised to the power 4 times 3 raised to the power 5 times 3 raised to the power 2, all divided by 3 raised to the power 6 times 3 raised to the power 3. Don't forget that the number 3 is the same as 3 raised to the power 1, because 3 raised to the power 1 is the same as 3. This means that 3 is the same as 3 raised to the power 1. So 3 raised to the power 4 times 3 raised to the power 5 times 3 raised to the power 2, all divided by 3 raised to the power 6 times 3 raised to the power 3 is equal to. Now, when we consider the numerator, we can see that the numbers are of the same basis, and the base is 3. And so, according to the first law of indices, we keep one of the basis constant and add the exponent together. So we have 3 exponents 4 plus 5 plus 2, all divided by 3 exponents, we have 6 plus 1 plus 3. This means that 3 raised to the power 4 times 3 raised to the power 5 times 3 raised to the power 2, all divided by 3 raised to the power 6 times 3 raised to the power 3 is equal to 3 raised to the power 4 plus 5 plus 2, divided by 3 raised to the power 6 plus 1 plus 3. Now 4 plus 5 is 9, and 9 plus 2 is 11. And so we have 3 raised to the power 11, all divided by, when we add 6 to 1, the result is 7, and 7 plus 3 is 10. And that is how come we have 3 exponent 10. Now we have 3 raised to the power 11 divided by 3 raised to the power 10, and this can also be expressed as 3 raised to the power 11 divided by 3 raised to the power 10. Now these numbers are of the same basis, but they are dividing, and therefore according to the second law of indices, when you keep one of the basis constant, you subtract the exponent. And so we have 3 raised to the power 11 minus 10. That is 3 raised to the power 11 minus 10, because the numbers are of the same basis and they are dividing. Now when you subtract 10 from 11, the result is 1. So 3 raised to the power 1 is equal to 3. 3 raised to the power 1 is equal to 3. Now let's look at the properties of indices. The properties of indices. 1. A raised to the power minus 1 is equal to the reciprocal of the number. That is, a raised to the power minus 1 is equal to 1 over a. For a is not equal to 0. For a is not equal to 0. Example, 2 raised to the power minus 1 is equal to 1 over 2, because the number is 2. So 2 exponent minus 1 is the reciprocal. That is 1 over the number. So 1 over 2. Property number 2. A raised to the power minus n. Now the exponent is a number. You have minus of the number. So you have a raised to the power minus n. That is a number other than 1. A raised to the power minus n is equal to 1 over a raised to the power n. You can see that the negative exponent has now changed to positive exponent because of the reciprocal of the number. And so a raised to the power minus n is equal to a raised to the power n is equal to 1 over a raised to the power n. I repeat, a raised to the power minus n is equal to 1 over a raised to the power n is equal to the reciprocal of the number, but the negative exponent changes to positive exponent. For a is not equal to 0, because if a becomes equal to 0, 1 over a raised to the power n will cease to exist. So for 1 over a raised to the power n to exist, a must not be equal to 0. A must not be equal to 0. Now property number 3. A over b, all exponent n, is equal to a raised to the power n divided by b raised to the power n. What this property means is that if you have a over b in bracket exponent n, take note that a over b is a fraction. The numerator is a and the denominator is b. Now this property means that the exponent is affecting both the numerator and the denominator of the fraction. And therefore a over b exponent n is equal to a raised to the power n all divided by b raised to the power n. That means that the exponent is affecting both the numerator and the denominator. Let's look at this example. If you have 2 divided by 3 raised to the power 2, this is equal to 2 raised to the power 2 all divided by 3 raised to the power 2. That is, the exponent is affecting both the numerator and the denominator. Now 2 squared is equal to 4 and 3 squared is equal to 9. This means that 2 over 3 all exponent 2 is equal to 4 over 9. Now property number 4. We have a over b all exponent minus n. The only difference between property number 3 and property number 4 is the exponent. For property number 3, the exponent is positive, but for property number 4, the exponent is negative. Now let's look at what the property says. A over b exponent minus n is equal to b over a exponent n. Now you can see that the numerator becomes the denominator and the denominator becomes the numerator. And when that happens, the negative exponent changes to positive exponent. That is, a over b all exponent minus n is equal to b over a exponent n. That is, the b goes up and the a comes down, and as soon as that happens, the negative exponent must change to positive exponent. Now we are back to property number 3, which says that the power or the exponent n is affecting both the b and the a. And so b over a exponent n is equal to b exponent n divided by a exponent n. Now example, if you have 2 divided by 3 all exponent minus 2, this is equal to, the denominator becomes the numerator and the numerator becomes the denominator. As soon as that happens, as soon as 3 goes up and 2 comes down, the negative power changes to positive power. And that is how come minus 2 has changed to positive 2. Now, according to property number 3, the exponent 2 is affecting both the 3 and the 2. And so 3 over 2 all exponent 2 is equal to 3 squared divided by 2 squared. Now 3 squared is equal to 9 and 2 squared is equal to 4. So the answer is 9 over 4. Now let's look at property number 5. A raised to the power 1 over n a raised to the power 1 over n is equal to the n fruit of a. What do you mean by that? If you have 4 raised to the power 1 over 2, when you look at the exponent, it's a fraction. The numerator of the fraction is 1, and the denominator of the fraction is 2. And so if you have 4 raised to the power 1 over 2, is the square root of the number. That's the denominator's root of the number. The denominator's root of the number. So 4 raised to the power 1 over 2 is equal to the square root of 4. And square root of 4 equals 2. Now 8 raised to the power 1 over 3. The denominator of the exponent, the fraction, is 3. And so 8 raised to the power 1 over 3 is the cube root of the number 8. Is the cube root of the number 8. And cube root of 8 is equal to 2. Now let's look at this example. Without using calculator, evaluate 25 divided by 64 exponent half. B, 8 over 27 exponent minus 2 over 3. Now let's look at the solution. 25 divided by 64 exponent half is equal to 25 raised to the power half divided by 64 raised to the power half. This means that the exponent is affecting both the numerator and the denominator according to property number 3. And so 25 over 64 raised to the power half is equal to 25 raised to the power half, all divided by 64 raised to the power half. Don't forget that we said that a number raised to the power half is the square root of that number. And so 25 raised to the power half is the same as the square root of 25. And 64 raised to the power half is the same as the square root of 64. And the square root of 25 equals 5. Square root of 64 equals 8. And so this is equal to 5 divided by 8. So 25 divided by 64 exponent half is equal to 5 divided by 8. Now let's look at an alternative approach of solving the same problem. We were given 25 over 64 exponent half in the question. Now according to the third property, this is equal to 25 raised to the power half divided by 64 raised to the power half. Now our concentration is on the exponent. The exponent is half. The denominator of the exponent is 2. Our concentration is on the denominator of the exponent. Now the denominator of the exponent, that is the fraction, is 2. The denominator of the exponent is 2. And so what we are going to do is to express 25. Is to express the number 25 as an exponent which will be equal to the denominator of the exponent half. And 25 can be expressed as 5 raised to the power 2. Now we realize that the exponent is now equal to the denominator of the fraction. That's the exponent outside the bracket. Now 64 can also be expressed to have an exponent of 2. And 64 can be expressed as 8 raised to the power 2. And so 64 is the same as 8 raised to the power 2. Now all exponent half. Now why did you do this? This is because the exponent 2 can now cancel the denominator of the exponent. And so 2 will cancel 2. And 2 will also cancel 2 here. Now we are left with 5 raised to the power 1. All divided by 8 raised to the power 1. Or, according to the third law of indices, if you have 5 raised to the power 2 into bracket, all exponent half. All divided by 8 raised to the power 2 into bracket, all exponent half. The exponent in the bracket multiplies the exponent outside the bracket. And so, this is equal to 5 raised to the power 2 times half. All divided by 8 raised to the power 2 times half. And now, when the 2 cancels the 2, we are left with 5 raised to the power 1. And that is what is shown here. All divided by, when the 2 also cancel these 2, we are left with 8 raised to the power 1. And that is what is shown here. And therefore, we have 5 raised to the power 1 divided by 8 raised to the power 1. 5 raised to the power 1 is equal to 5. And 8 raised to the power 1 is equal to 8. And so the answer to 25 over 64 raised to the power half is equal to 5 over 8, which is the same answer as we had when we used the alternative number 1. Now let's look at the solution to the question in B. We were given 8 over 27 raised to the power minus 2 over 3. Now we can see that according to the property number 4, when the 27 goes up and the 8 comes down, that's when the denominator becomes the numerator and the numerator becomes the denominator. The negative exponent quickly changes to positive exponent, and that is how come minus 2 over 3 has now changed to 2 over 3. It is because 27 has now gone up and the 8 has now come down, and therefore the exponent now changes to 2 over 3. Now 27 can also be expressed to an exponent 3. Why are we expressing 27 to an exponent 3? This is because the denominator of the exponent is 3, and so 27 is also expressed to an exponent 3, and 27 can be expressed as 3 raised to the power 3. 8 can also be expressed as 2 raised to the power 3. Now, according to the third law of indices, the exponent we have in the bracket multiplies the exponent outside the bracket. And so 3 raised to the power 3 into bracket exponent 2 over 3, all divided by 2 raised to the power 3 into bracket exponent 2 over 3 is equal to 3 raised to the power 3 times 2 over 3. That is the exponent in the bracket multiplies the exponent outside the bracket. So we have 3 raised to the power 3 times 2 over 3, all divided by 2 raised to the power 3 times 2 over 3. Now 3 cancels 3 and we are left with 2. So we have 3 squared, and that is how come we have 3 raised to the power 2 here. When 3 also cancels this 3, we are left with 2 squared, and that is how come we also have 2 squared here. Now 3 squared is equal to 9 and 2 squared is equal to 4. This means that 8 divided by 27 raised to the power minus 2 over 3 is equal to 9 over 4. Is equal to 9 over 4. Now let's look at the alternative approach. Given 8 over 27 exponent minus 2 over 3. When 27 goes up and the 8 comes down, quickly the negative exponent has to change to positive exponent. Now we understand this according to property number 4. Now, the exponent is affecting both the numerator and the denominator. But we can see that 2 over 3 can be expressed as 1 over 3 times 2. Because if you multiply 1 over 3 by 2, you are getting back 2 over 3. And therefore, 2 over 3 can be separated as 1 over 3 times 2. So we move the 1 over 3 into the bracket and we move the 2 outside the bracket. The same thing happens to the denominator. We move the 1 over 3 into the bracket and we move the 2 outside the bracket. Take note that we are not changing anything because 1 over 3 times 2 is the same as 2 over 3. This is because anytime a fraction multiplies a whole number, it is the numerator of the fraction that multiplies the whole number. And so assuming we are multiplying 1 over 3 by 2, it is the one that multiplies the 2. And 1 times 2 will give us 2, all divided by 3, and we are back to this. So take note that we are not changing anything. We are only separating 2 over 3 as 1 over 3 times 2. So we move 1 over 3 into the bracket, then we move the 2 outside the bracket. The same thing happens to the numerator, and the same thing happens to the denominator. Now in the bracket we have 27 exponent 1 over 3, and we said that 27 raised to the power 1 over 3 is the cube root of that number. And so 27 raised to the power 1 over 3 is the cube root of 27. Don't forget, it's all exponent 2. It's all exponent 2. All divided by 8 raised to the power 1 over 3 is also the cube root of 8. All exponent 2. Now when you take the cube root of 27, the result is 3. So we have 3 exponent 2. All divided by, when you take the cube root of 8, the result is 2. And don't forget your exponent 2. So we have 2 squared. Now 3 squared is equal to 9. And 2 squared is equal to 4. And we can see that the answers are the same. As the answer, this answer is the same as the answer we had when we used the alternative number 1. Now we look at exponential equation. Exponential equation. An exponential equation is any equation which involves an unknown quantity as an exponent or index. Now in b exponent x equals b exponent y. On the left hand side, the base is b and the exponent is x. On the right hand side, the base is b and the exponent is y. So we can see that the left hand side is equal to the right hand side in terms of the base. So when the left hand side is equal to the right hand side, we can equate the exponent. So b raised to the power x equals b raised to the power y implies that x is equal to y. We are equating the exponent because the bases are the same. So because the bases are the same, we say that x is equal to y. That's the exponent on the left hand side is equal to the exponent on the right hand side. That is the exponential equation. Now, let's look at this problem. If 3 raised to the power x plus 1 is equal to 3 raised to the power 3. Now we can see that the left hand side and the right hand side, they all have the same basis. And therefore, quickly we can equate the exponent. The exponent on the left hand side is x plus 1. And the exponent on the right hand side is 3. And so x plus 1 on the left hand side is equal to 3 on the right hand side. So if x plus 1 is equal to 3, how do we make x the subject? Making x the subject means that x must stand alone, and therefore plus 1 on the left hand side becomes minus 1 on the right hand side. So x is equal to 3 minus 1, and 3 minus 1 is equal to 2. This means that the value of x, for which 3 exponents x plus 1 equals 3 exponent 3 is equal to 2. So the value of x is equal to 2. Now we can prove this by substituting 2 wherever we see x, and in doing that we have 2 plus 1, and 2 plus 1 equals 3. That means that we have 3 raised to the power 3, which is equal to the right hand side. So the value of x is equal to 2. Now for exponential equation, after solving for the value of x, when you substitute the value of x into the original equation and your left hand side of the equation does not become equal to the right hand side of the equation, then it means that there is something wrong with the value you had, so you have to go over. It's very important. Take note, for exponential equations, whatever you get for the variable, when you take it back to the original equation and the left hand side is not equal to the right hand side, it means that there is something wrong with what you have done, so you have to go through. Now in this case, the value of x is equal to 2. Now let's solve the equation. 3 raised to the power x equals 27. B, 3 raised to the power 2x minus 2 is equal to 81. C, 9 raised to the power 4x equals 243. Let's look at how best we can solve this problem. Now solution. Let's look at the solution to the problem in A. We were given 3 raised to the power x equals 27. Now the bases are different. The base on the left hand side is 3 and the base on the right hand side is 27. Take note, the exponent here is 1. But 27 raised to the power 1 is the same as 27. So we have to express 27 also to have the base 3 so that we can equate the exponent. And 27 can be expressed as 3 raised to the power 3 because 3 raised to the power 3 is the same as 27. Now we can see that the bases are now the same, and therefore we can equate the exponent. The exponent on the left hand side is x, and the exponent on the right hand side is 3, and therefore x is equal to 3. Now, if you want to prove that the value of x equals 3, you only substitute 3 wherever you see x in the equation. And so, we have 3, instead of 3 raised to the power x, we have 3 raised to the power 3. And 3 raised to the power 3 is equal to 27. So, you see that the left is now equal to right. That means that the value of x is equal to 3. This is what I was talking about. Now, we look at solution to question B. 3 raised to the power 2x minus 2 is equal to 81. The bases are not the same, so we have to express 81 to have the base 3. Now 81 can be expressed as 3 raised to the power 4. This is because 3 raised to the power 4 is the same as 81. Now the bases are the same, so we equate the exponent. The exponent on the left hand side is 2x minus 2, and the exponent on the right hand side is 4. And so equating the exponent, we have 2x minus 2 equals 4. Now we are making x the subject. So quickly minus 2 on the left hand side become plus 2 on the right hand side. What are we doing? We are only arranging all the constants on the right hand side and the term with the variable on the left hand side. And so minus 2 crosses the equal to sign to become plus 2 on the right hand side. Now 4 plus 2 equals 6. So we have 2x on the left hand side is equal to 6 on the right hand side. Now we are making x the subject. So we have to divide the left hand side by 2. And so we divide the left hand side by 2, and whatever we do to the left hand side of the equation, we have to make sure we do the same thing to the right hand side of the equation so that the equation will not be changed. And so when we divide 2x by 2, we have x. Dividing 6 by 2, we have 6 over 2, and 6 divided by 2 is equal to 3. This means that the value of x is equal to 3. This means that the value of x is equal to 3. So for your exercise, you can substitute 3 wherever you see x in the exponential equation and see whether your left will be equal to the right hand side, that is 81. Now we look at the problem in C. Given 9 raised to the power 4x is equal to 243. Now if you look at what we have here, 9 raised to the power question mark is equal to 243. Now let's look at this. On the left hand side, the base is 9. And on the right hand side, we have 243. So we have to express 243 also to have the base 9. But 9 raised to the power no whole number can give you 243. I repeat, 9 raised to the power no whole number can give you 243. This means that we have to break the 9 also down to have the base 3. Because 243 can be expressed as 3 raised to the power 5. Because 3 raised to the power 5 is equal to 243. And 9 can also be expressed as 3 squared. So we have 3 squared, all exponents 4x. Now according to the third law of indices, the exponent 2 in the bracket can multiply the exponent 4x. And so we have 3 raised to the power 2 times 4x is equal to 3 raised to the power 5. Now when we multiply 2 by 4x, the result is 8x. And that is how come we have 3 raised to the power 8x. This is equal to 3 raised to the power 5. Now, the bases are now the same on both sides of the equation. And so we equate the exponent. Exponent on the left hand side is 8x. And exponent on the right hand side is 5. And so 8x equals 5. Now, let's make x the subject. Making x the subject means we have to divide the left hand side by 8. And we divide the right hand side also by 8. Dividing the left hand side by 8, we are left with x. When we divide the right hand side by 8, we are left with 5 over 8. So the value of x is equal to 5 over 8. Also, take this as an exercise. Substitute 5 over 8 wherever you see x in the exponential equation and prove whether the left hand side is equal to the right hand side. The value of x is equal to 5 over 8. Now let's take this question. If 2 raised to the power x is equal to 5, find x. Solution. 2 raised to the power x from the question was equal to 5. Now we can see that we have 2 raised to the power question mark. That is 2 raised to the power no whole number can give you 5. And therefore, in this case, we have to take the logarithm of both sides. And this will introduce us to logarithm. Now we take logarithm to the base 10 of the left hand side. And so we have log 2 raised to the power x to the base 10 is equal to log 5 to the base 10. Now, according to the third law of logarithm, the exponent x can take its position before the logarithm. I repeat, according to the third law of logarithm, the exponent x can take its position before the logarithm. So, log 2 raised to the power x to the base 10 can be expressed as x log 2 to the base 10. And the x is no more here again. This is equal to log 5 to the base 10. Now, because we are solving for x, we divide the left hand side by log 2 to the base 10. We divide the right hand side also by log 2 to the base 10. And so in doing that, we have x equals log 5 to the base 10 divided by log 2 to the base 10. Log 5 to the base 10 is equal to 0.699. And log 2 to the base 10 is equal to 0.301. And when we divide 0.699 by 0.301, the answer is through 2.32. The value of x is equal to 2.32. So the answer is a decimal. The answer is a decimal. That is why 5 could not be expressed as 2 raised to the power a whole number. Now let's look at simultaneous exponential equation. Solve simultaneously the equation 2 exponent 2x plus y is equal to 32. 2 exponent 2 into bracket x minus y is equal to 4. These are the equations we are given. These are the equations we are given. And now let's see how best we can solve this problem. Let's see how best we can solve this problem. From the question, we were given 2 raised to the power 2x plus y equals 32. Before we can equate the exponent, the bases must be the same. The base on the left hand side equals 2. And so we express 32 to have the base 2. And 32 can be expressed as 2 raised to the power 5. Now we have 2 raised to the power 2x plus y on the left hand side. Is equal to 2 raised to the power 5 on the right hand side. The bases are now the same, so we can equate the exponent. The exponent on the left hand side equals 2x plus y. And the exponent on the right hand side equals 5. And so 2x plus y equals 5. Let this be equation 1. From the second equation, we were given 2 exponent 2 into bracket x minus y equals 4. The base on the left hand side equals 2. And so we express 4 also to have a base 2. And 4 can be expressed as 2 squared. Now the bases are the same. That is 2. And so we can equate the exponent. The exponent on the left hand side is 2 into bracket x minus y. And the exponent on the right hand side is 2. So we have 2 into bracket x minus y equals 2. Now we expand the bracket. So we multiply 2 by x. And that is giving us 2x. 2 times minus y is giving us minus 2y. And this is equal to 2. Let this be our equation 2. Let this be our equation 2. Now solving equation 1 and equation 2 simultaneously. From equation 1 we have 2x plus y equals 5. Let this be our equation 1. And from equation 2 we have 2x minus 2y equals 2. This is our equation 2. Now we use the elimination approach to solve this problem. We can however use the substitution approach, but in this case we are using the elimination approach to solve the problem. Now we are eliminating y, but we can see that the coefficient of y in both equation 1 and equation 2 are of opposite signs. That means that before we can eliminate y, we have to add the two equations together. So we add the two equations together when they are of opposite signs. That is, we have plus and negative. But if the signs are the same, we subtract one equation from the other. Take note. Now, before you can add, you have to make sure the coefficient, the numbers are the same. The coefficient of y in equation 1 is 1. But the coefficient of y in equation 2 is 2. That is minus 2. So before we can add the two equations together, we have to multiply equation 1 by 2. And so in multiplying equation 1 by 2, we have 2 times 2x, and that is giving us 4x. We have 2 times y, and that is giving us 2y. And we have 2 times 5, and that is giving us 10. Now let this be equation 3. It is no more equal to equation 1 again because we have multiplied the whole of equation 1 by 2. Now we are going to solve equation 2 and equation 3. We can see that the signs are opposite, but the coefficients are the same, 2. So we can now add the two equations together. We add the corresponding terms together. So 2x plus 4x minus 2y plus 2y is equal to 2 plus 10. And so 2x plus 4x plus minus 2y plus 2y is equal to 2 plus 10. Now when we add 2x to 4x, that is 2x to 4x, the result is 6x. Minus 2y plus 2y, that is minus 2y plus 2y, will give us 0. And 0 plus 6x equals 6x. This is equal to 2 plus 10 is equal to 12. And that's how come we have 12 here. So 6x is equal to 12. How do we solve for x? We have to divide the left hand side by 6. And we divide the right hand side also by 6. Now dividing the left hand side by 6, we have x. And dividing the right hand side by 6, we have 12 divided by 6. And this is equal to 2. So x is equal to 12 divided by 6. And the result is 2. When we divide 12 by 6, it's equal to 2. This means that the value of x is equal to 2. The value of x is equal to 2. Now, putting x equals 2 into equation 1. From equation 1, we have 2x plus y equals 5. Now, let me show you this. You can put the value of x into any of the equations. And you get the same answer. But in this case, we are putting x equals 2 into equation 1. Now it means that wherever we see x in equation 1, we have to substitute 2. From equation 1 says that 2x plus y equals 5. Now x equals 2. And so we have 2 times 2 plus y equals 5. When we multiply 2 by 2, the answer is 4. So we have 4 plus y equals 5. We are making y the subject. So let's group the constant on the right hand side. And so 4 on the left hand side becomes minus 4 on the right hand side. And so we have y is equal to 5 minus 4. Now 5 minus 4 is equal to 1. This means that the value of y is equal to 1. This means that the value of y is equal to 1. This is the end of our presentation on indices.